The show starts in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, go.
Okay, hello you guys. Can you guys hear me clearly? Hi, Khánh Huy ha. Hi everyone. Welcome everyone to my live streaming today. Okay, currently we have 14 people. Okay, it's also good. So, okay, hi Khánh Huy again. Okay, so okay, let's get started. Let me introduce a little bit about Leetcode. Maybe somebody that don't know about Leetcode. Okay, Leetcode is a platform where you can practice to improve your coding skill. A lot of big company pick problem on Leetcode. So for the newbie, I suggest you can go to the Leetcode and study plan, and you can practice to solve problem that Leetcode already prepared for you. Yeah, you can see that in algorithm we have algorithm 1, algorithm 2. All of them take about 800 problem, right? 800 problem. No, not 880 problem. 80 problem, and data structure as well. Data structure also about 80 problem, and this maybe 80. So totally we have 240 problem for you to check your coding skill. And Leetcode also have daily challenge. I highly recommend you guys show daily challenge so that you can get some coins when you show fully daily challenge. Yeah, why you can improve yourself. And I also highly recommend you guys to join Leetcode contest every week, and by weekly contest. This is happen on the Friday every 2 weeks, and this one happen on Sunday every week. So if you guys take the top, you guys can earn a lot of coins. Where you guys can, if you guys on the top one, right? You guys have 5,000 coins, where you guys can order a lot of t-shirts from Leetcode and Leetcode laptop sleeves or other thing. Actually, in my experience, those new problem in the Leetcode contest, this problem is from big company like Google, Facebook, or other company. Someone leak that problem maybe 6 months ago or 1 year ago, and they Leetcode they remake it to become a valid problem on Leetcode. Okay. Cheer for King Hu. Okay, hello. Okay. Okay. So today I will continue my series about to show mock assessment. This feature is only for premium user. So actually, that when I choose a company, there are 3 sessions: online assessment, phone interview, and on-site interview. When we start, it will choose a random problem set, and each problem set can contain up to 4 questions. Okay, so as a title for today, we focus on problem on Google Onsite interview. Okay, so let's get started. Are you guys ready? Okay, let's go. First of all, let me zoom a bit so you guys can see clearly. Okay. Okay. Oh, this problem set have 4 questions. Quite long. Okay. Let me read the problem first so you guys can understand clearly. Then I will go through example and I will explain my idea and I implement and I will tell you guys time complexity and space complexity. Okay. The first problem that there is a robot starting at position 00. The origin on 2D planner given a sequence of its move. Just if this robot ends up at 00 after it completes its move, you are given a string moves that represents the move sequence of the robot, where moves I represent I's move. Valid move are right, left, up, down. Return true if the robot returns the original after it finishes all its move, or false otherwise. The way that the robot is facing is irrelevant, or will always make the robot move right one right left, will always make it move left once also right. Also assume that the magnitude, what is magnitude? Magnitude, okay, the size of robot, right? Magnitude of the robot movement is the same for each move. Magnitude of the robot movement is the same for each move. Okay, let's go through example 1. So we have this move, right? So currently that robot is 00. So how to draw the map? Okay, we can imagine first. First of all, if you go up in this version, right? Go up and down, so it will do. Okay. Robot up once and down once. All the move have the same magnitude, so they end up the original where they start. Therefore, they return true. Okay. And the second example, go left, right, so it will return false. The robot move left twice, it end up to move to the left of the origin. We return false because it's not at the origin at the start end of each move. Okay, this one we go right, and down. So it will return false as well. This one also false. Okay, so how to show this problem? We can just follow the direction. For example, that first we are at we are at position 00, right? 00. If we go up, we will update the new position. We down, we update the new position. And finally, after we finish, we just return if the current position is 00 or not. That's simple, right? Okay, so let's solve it. Let's implement. Okay, thank you, Chairman. Actually, that my English is a little bit English. Okay. Okay. Start. Let's round as a current round, right? Round and column 00. Okay. This is the move, right? So if move equal to up, right? My row will go up, right? So it will -1. My column, right, will the same. the same with if move down, so row will plus 1, else if m equal to left, right? Left we go to left, so column will minus 1, else column will plus 1, and finally that we return row equal to 0 and column equal to 0 another. Okay, let's run. 2 4 4 4, right? This problem seems straightforward. Okay. Okay. This problem is quite easy for us to warm up. Yeah. Right, increase it. Yeah, correct. So this problem is quite straightforward. So the time complexity for this will be we do the linear, so ON, we n is length of the moves right here, and the space complexity is O1. Okay, so let's move to the question 2. This problem is quite straightforward, right? Okay. Question 2. Sometimes people repeat letters to represent extra feeling. For example, hello, they say hello. Hi, they say hi. In this string like hello, we have groups of adjacent letters that are all the same H, E, L, L, O. Okay, you are given a string and an array of query string words. A query word is stretchy if it can be made to be equal to S by any number of application of the following expansion operation to a group of consists of characters S is C and add some number of characters C to the group so that the size of group is 3 or more. For example, that starting with this word hello, we could do an expansion to the group O to get hello, but we cannot get hello since the group, this one, right, have the size less than 3. Also, we could do another extension like this one go into this one. Okay, we get this one. So if this one, then the query word hello would be stretchy because of these two extension functions. Query being equal to hello, so hello. Okay, for this, right, we stretch the O here, so it will become 3O here, and then we can stretch the LL here to become LL here. Okay, so return number of query string that are stretchy. This problem is a bit hard to understand. So let's check the example. So we can. So let's check this first. Following extension operation to a group of consists of character C and add some number of character C to the group so that the size of group is 3 or more. The size of group is 3 or more time or something. How about why this one hello, right? Why which we don't just add 1L but they add 3L here. To a group of consists of characters C and add some number of characters C to the group so that the size of group is 3 or more. Okay. Okay. For this example, right, we can extend hello here. We can extend E and O in the word hello to get hey, because we need to add at least 3, right? Hey, and O here low. We cannot extend this one to get for this one, right? Or this one we cannot extend to get this one because group is not size 3 or more. Actually, that if we extend, right, we need to extend to 3 or more, but the expectation have only 2 character error. Okay, so this one not valid, correct? And how about high? How about high? High can okay. High maybe default. Okay. So return number of query string that are stretchy. Okay. They will give us the list of words here as a query, right? The query word, right? We will stretchy because to extend operation. Okay, stress on L and stress on O. Okay. So actually, the problem said that given the word list here, check if this word can be stretchy to become the string S here. Return the number of words can stretch. So for example, this one return hello here because hello can stretch to this one. Okay. For the example 2, let's check example 2. Okay. For this word, right? Can we stretch? We can stretch y z, right, and y, right? Yeah. So this is valid one. So this one also stretch y z and y. So z and y. Okay. So this is 3 of words here is valid. Okay. So mm, mm, from the input here, so do it have any picture? For example, that age we have 1, right? A we have 1, E we have 3, L we have 2, O we have 3. How about this one? Age we have 1, E we have 1. 1 can stretch to 3. Okay. L here need to match all of them. So L here, so it need to extend minimum is 3, and this doesn't contain 3, doesn't have enough 3, so it's return false. So what's idea here? Idea here is maybe we will start from if you want to save okay, the first one is that we start index of the words here. For example, age, right? We start with, for example, L here. We mark all of them. For example, age here only one single character, so we have age here with the length E2, length E1. So we need string S here at least can be 1 or more than have 2 cases. K1 is count of age needs to be equal to 1, or count of age needs to greater or equal to 3. So we can greater equal to max of 3 and count of words here. For example, that if words here, right, have 4 characters, so we need to count of 8 here. So let's make count 8 here to distinguish. Okay, right. First of all, that this one can be 1, right? Or if this one stress, if it one stress, so if it's stress, so the minimum size is 3. The minimum size, for example, if this one is already 4, right? So we need to pick 4, and this need to greater or equal than the size. Then we move to the next one. First of all, we may pre-compute the string s, so that we can have up. We can speak our algorithm. Okay, so my idea is that I will have the util function from this string here. I will compress them for them. Okay, I will have a function like how to say compress them, and a string here. I will output like a catcher and if number of catcher. Okay, so I will start count here, alright, and I large catcher, right? Large catcher, I will choose any catcher that's different from a lowercase letter. For example, that this one, and I look from my string here. If c equal to last catcher, right? And I increase the count. Otherwise, if it's different, right? Different, the count will be 1. Okay, and I update last character here. Okay. If it's different, right? If so the first time it will different. Maybe the first time we make it equal. So that when it different, right? When it different occurs, we can push into our array a pen with the character and count. Okay, the character and it count. The last character and it count. It count here. Okay. Okay, and then I will check the last one. If count is always we need to always add the last one as well. Okay. Okay, return our array here. Let's check our algorithm. Let's test compress here with the string s here. So let's print this is how to say array 1 or something. Array 1, array s or something. Okay, we print to test. Okay, so if you compress h1 here, right? E3 is not correct. So okay, if it's equal, right? Can we plus 1? Can we plus 1? If it's different, right? Different, I need to ask the last one. And I reset to 1. So what's wrong here? So I meet first of all, last catcher will be h, and this one is correct. So count will be 1, and I meet e. It's mid match here, so I add 8 with 1 here, and I reset count equal to 1, and the last character is e here. Last character is e here. Okay, then I will check e here equal, right? So it will yeah, it's correct. H1 here, E3 here, L2 here, O3 here. Okay, it's correct. Kind of poor written question description. Yeah, very long. You actually that for cost for problem or other problem they will have a very long description. Then that Leetcode is short enough for us. But I think this this problem need to have more description. So that okay. So let's continue. So I already built the compress function correctly, right? So after I have age here, I will just look to check my words here, and then I just have the problem. Indent problem. So wait me go to this. I will show the indent problem. Okay. In right? In. Sorry. Okay. That's why I have indent problem. Okay. In here. Okay. No indent problem anymore. Okay. So we have array words here. I will compress the words here, so I can have the array of words here. Okay. How to compare? Like I said before that. If the length of each word is minimum is 1 and the length of s is minimum 1, so we don't need to care about sk. Okay, how to check? So actually that I think first of all the size of a word here need to equal the size of s here, right? Because we are separate by letter, right? So they need to match the size. For example, that this is 4, so this need to 4 A E L L and O 4 group, and this one 4 group. Yeah. So each length of this one different with length of array S, right? Reason false because mismatch number of groups. Okay. This is the first condition. Okay. The second condition is we look through into the whole length, right? So we like I said here. So count h here equal to 1. Actually not equal to 1 because for example that it's 2. So so equal to count w of h, right? This is the first case if we don't extend, right? This is don't extend, and this is the second case that we extend, that we stretchy, and this is no stretchy. So if no stretchy, the length of this one need to equal to length of this one. Right. The second one, if we stretchy, it's minimum will be max of 3, and this one need to greater our minimum. Right. Okay, seem correct. We need to compare the catcher as well. So if the catcher is mismatch arrays of index here, and the catcher here is mismatch with array of s index I and 0 here. So we return false. No, we don't refer. Actually, that we are in loop here. So we may have a function like test our words here to correct or not. Okay, so we have answer here equal 0 here. If test of word, right, correct, right, we answer +1. Return our answer here. Okay. Mixed math, and this mixed math mismatch letter. Okay, it return false. Otherwise that if case one no stretchy and this one stretchy one. Okay. If it's not equal to one of them, so it means that if two of them are failed, we return false. So it's different, right? It's different. Count is the array of I here, and the count, right? The count is different. So let's swap this to be synchronized. Okay. I here. Okay, K1 the count is different, and maybe we are and not for us to easy to understand. It is not like this. We need at least one condition true, right? We need to at least equal or K2, that's a count of I here, and the count here will greater equal to at least 3, and count this one and 1, right? Okay. If it's not, return false. Okay. Otherwise, we return true. Okay. Let's run the test. Count is not a count. It's a array. Okay. Okay, seem correct. So let's check my algorithm again. So the compress here is already correct. And test here. I for work in my words I test if work is a strategy. So I will increase by 1. How to test strategy? I get the array here. If the number of group is mismatch, I return false. Otherwise, they are equal length, right? I loop the index I through its element. If it mismatch the catcher, I return false. Otherwise, that I need at least one condition here is true. First of all, no stretch, right? They need to equal the catcher count. If it needs stretch, right? So this one stretch at least 3, and this at least the size of the length of array we get here. Okay. Okay, seem correct. If mismatch return false, otherwise return true. Okay, let's submit. Okay, correct. So okay. Explain K2 please. Okay. So ask me to explain K2 please. Okay. K2 here, right? For example, that E here. When I stretch it, right? I can stretch at least 3. At least 3. So when I stretch, I can stretch 3 or more, and at least 3. So I need to check this one is greater or equal to 3, right? Because when I stretch, I can stretch 3 or more. So I need to check this one is greater or equal to 3. But we need to max with this one as well, because for example that if this one is already have something like this, it's have 4, right? So this one, if this one is 3, it's not mismatch, right? So it's at least to the count of this catcher as well. So we max 2 of them. Yeah. Okay. Do you understand now? Okay, so the time complexity for this for for the S here, we pre-compute. It has we do the linear time here. So okay, you got it. Okay, the time complexity for this one will be linear time. So it will be length of string S, length of string S plus with for each word here, we need to do the linear time here, compress here, right? Multiply by the length of word, and something like that. For this love is up to this love is up to length of get. So it's this one like this one, but we can remove this one. So this is the time complexity. For the space complexity, for the string S here, in the worst case can come into length S, and the worst as well. The worst here in the worst case will come up to IFW, because for K like this, all letter are different. All letter are different. If you add with the size is equal to length of S or length of W. Okay, so okay, and this one don't store. This one just you up to size of gap. Okay, so this is the space complexity. Okay. Okay, so go let's go to the next question. Okay, we have question 3 here. So on a 2D plan, we place n stones at some integer coordinate point. Each coordinate point may have at most one stone. We have 2D plan. We place n stone at some position at the integer value, and each coordinate point may have at most one stone. So it means that 0 stone or 1 stone. Okay, a stone can be removed if it shares either the same row or the same column as another stone that has been removed. Given array stone of length n, where stone I equal to the position, right? The x here represent location of the I stone. Return the largest possible number of stones that can be removed. Okay, let's go through example first. Example 1 here. We have this stone. So it said this line said that there are n stone and each position have at most 1 stone. Okay, and a stone can be removed if it share the same stone can be removed if it share the same row or column with another stone as another stone that has been removed. Given a stone this return the largest possible stone can be removed. Okay, for this I think we need to draw to see clearly. Okay. Okay. For we have position here is from 0, right? From 0. Okay. We have this okay. For the first stone will be 0 0. Okay, 0 0. It's hard. Okay. For the next will be 0 and 1. Have to draw. Okay, 0 0 here, 0 0 0 0 here, and 0 and 1 here, and 1 and 0 here, 1 and 2 here, 2 and 1, 2, 1 and 2, right? 2 here and 1 here. Okay, 2 and 2. 2 and 2 here. Okay, so we have this one. Okay, so return the largest possible number of stone that can remove. Remove stone 2 2 because it share the same row with 2 1 2 1 here. So remove. Let me change the color. So remove this one because it share the same rows. The same row, right? The same row. Okay, with 2 1 here. Okay, remove this one. Remove 2 1 because share the same row with 0 1. Remove this one as well because it share the same column with 0 1. Okay, remove stone 1 2 1 2 because it is share the same row with 1 0 here. Okay, remove this one. Okay, remove 1 0 1 here 0 here. You want 0 here because it share the same column. 1 0 this one because it share the same column with 0 0 here. Okay, remove this one. Remove 0 1 0 1 here because share the same row with 0 0. Okay, so we remove 5. Remove 5. So return the largest possible number of stone that can be removed. Okay, so it need to find the maximum number of remove that we need to make a maximum number of remove. What happens if we just remove with just a grid D to remove? Grid D to remove. For example, that it seems like it's how about we group them together? For example, that this one and this one we group together. This one and this one we group together. This one and this one we group together. And this one and this one group together. This one group together. So it's just like have the one component here. So if we delete all of them, we keep one element. So this component have 6 points, right? We just keep one. So actually, maybe this it count the number of components, right? Seem like it count the number of components because when all this one belong to the same component, right? So we can remove any of them, right? How about this one, right? And this one, and this one next something. This one and something like this. And this one from a component, right? So if we just remove this one and remove this one, remove this one, remove this one, remove this one. It's not affect anything, right? We just remove one by one. So I think this is just to find the number of components. Actually, this one found a component. So found one component. So we return. So we return one. So we delete 5 number of component returned by. So this form a 6 here. We minus 1 because this we keep this one. So it's we delete 5. Okay. How about this example here? Let's go to check another example. Okay, this one. Let's check this one. If it okay, 0 0 here, 0 2 here, 0 2 2 here. Okay, and 1 1 1 1 here. Okay, 2 0 here, and 2 2. That's right. So it look like that we have two components here, one component like this, and this one another component. So for this component like this, we need to remove 3, and this one we don't remove this one, right? This one make a component, so we just remove 3, number of remove, right? And this one we don't remove. Yeah. So actually that first of all we need to count number of components. So in this graph, right, we have one component with 4 elements here, and one component with 1 element here. So actually that we need to return number of delete, right? So we need to delete the size of component -1, size -1. Okay, and we look and it's a minimum is 1 value, 1, minimum 1. Okay, so we need to min of get max of size of component -1, and with 1 at least 1 element. Okay. Okay, so do you guys understand? Good observation. Okay, yeah, okay. So okay now. So our problem here is to group them together. So how to group them together? We can use a structure named union file data structure to group them together. So okay, so how to group them together? We just group by row and column. So if group them by row and column, so each point here, right? If you have row here and column here, okay, we have a row ID and column ID here, and we need to union for example this one with we need to add to our union file. So our union file we have a union file. We have a union file and the union file have our union file have ID in range 0 up to number of row plus number of column here. Okay, so when we mix this point, right, we seem like we union for example this one we union row with column together, row and column together. Okay, in this case, right, in this case, for example 1 here and this one 2, right? So row is 1 and column this is row is 2. We are in XY coordinate, so maybe I use XY. Okay, so for X here, if you I define X here, we have the range from 0 to like this. Okay, and I need to define ID of Y here. Have the ID range will be greater than this one. So I need to avoid duplicate with X here. So I have my original Y here. I plus with the the length of x here, maximum of x here to avoid duplicate. So maybe I plus with this one to avoid to avoid x and y ID be the same. So I just merge row and x and y here together into the group. So for example, that I merge xe1, right, and column here, right, column here, y here, right, y here e2 plus with this one. So I have some constant value plus what 2. Okay, so I merge union 1 and m plus with 2 together. Okay. Okay. So for example, that we are consider this point, right? We are consider this point. It have we union 1 and m plus 2 together. Okay. So how about this one? This one we are union 1 with 0 here plus m. We group this one together. So if we do like this, right, we group one here and this one together. It's in our union file we have one here, a union file, and m plus 2 here is a union file. And when we merge m 1 and m here, so it means that if you merge, we are merge 1 and m plus 2, right? So this is the first and the second one is we merge 1 and m together, right? So we have look like we have 3 components. We have 3 components. Maybe no need 3 components is not correct. So we may do like easy way like easy way like for row, right? We will linear time. We will have a map something like this to merge element the same row together, element the same column together, something like that, and then we merge them. Explain in short again, please. Please explain again. Maybe union file data structure a little bit. Explain. You guys can try find number of components by using DFS. While finding number of components, we use weekly pattern component a group. In a component of endpoint, you can weekly remove. Yeah, as Dang Huy Nguyen explained to you guys, I already come through 2 examples and I found the pattern. So okay, let find the algorithm to solve this first. Okay, I need to merge them together. How about if I using the map, it can work. Map by column, map by rows, this can work. If I DFS this one go to its neighbor, right? Neighbor of for neighbor. We need to check DFS can also can So someone asked that what is union file data structure? What is the so to understand the union file, so you guys can go to this algorithm and can check this join big set here. So actually that what it does that it have the operation like union not A and not B together, right? For example that for example that oops, for example that for example that we have 1 2 3 4 and when we want to merge 1 and 4 together, currently if we have 4 vertex like this, right? We have currently we have 4 components for 4 component here, 4 different components. So if we can have the operation like union file of not A and not B together. For example, that union file not 1, 2, not 4, and not 4 together. So we merge them together. So the number of components now we have one component that contains 1 and 4, 1 and 4 here, and we have a component 2, component 3. So we have 3 components. So if we merge 3 and 2 together, so we have 2 components. Example like this. If we merge this one and this one together, so we have 1 component. So this is basic operation of union file. Okay, let me implement a union file for you guys to see. Okay, okay. I think we don't have so much time for this. Okay, so first of all, I will group by rows and column. So I will have the map group by rows, something like that, and this is a default list. I will ask. I look through my stone here, right? My stone here have a position X and Y here in my stone here, and I not by rows, by X. Okay, by X is rows as well. X is a column. X is a rows. Okay, X is X not a row. Y is a row. So column and row here. Okay. Column and row here. Okay, Y is column and X is column and Y is row. Okay, so I group by rows of a row here, right? I append my column. Something like this, and I have the same with group by column. Right, I group by column of column here. I append row here. So let me bring for you guys to see. Okay. So okay. This one a bit. Okay. For it's a bit dirty now, but okay. So for the first we group by row, right? So row 0 will have 2 points, which is 0 0 and 0 1, right? For the row 1 we have 2 points, right? 1 0 and 1 2, right? 1 0 and 1 2 here. It's the same with the 2. We have 2 points here, which is 2 and 1, 2 and 1 here, and 2 and 2, 2 and 2 here. Okay, the same with column. Okay, so it's correctly. Okay, so we need to unify. So unify. Let me implement and explain you guys. So this is the basic implement of unify. So I have the initialize constructor here. I need to pass the size of unify, and I have the parent view, the parent, right? Parent, all of them will be currently the parent of all component ID Excel in green side here. Okay. For example, that we have three components, and each ID E0, 1, and 2. So we have 3 components initialize. Okay, and we don't need to merge by union by rank or by size. Union by rank or by size. This by union by rank and by size, we can optimize together with the bus compression. We can optimize to OM plus N. But for simple, I use this one path compression only. Okay, so I have the depth here with the file parent file. Okay, I'm gonna to find the ID of the current component. Okay, so how to find the ID? So if O U is equal to parent of it, so it means that it point to the same component already. So return O. Otherwise, I will find with the bus compression and return this one. Okay, and I need to define union as well, O and V. Okay, PU is parent of U, parent of not U will be phi of U, and PV is size of V. Okay, phi of is the parent of not V. So okay, maybe our union file should our union file maintain the count of it? Okay, so if the union file maintain the count of it, no. This union file structure will store all the components. So later we will traverse on it. Maybe we have a size as well. This is a good combination. Okay, so finally that we look into their size, and we get the answer by size -1. Okay, the size. Okay, first of all, their size is 1. Okay, okay. So if du equal to is different, right? We equal already, right? So we don't need to unify and point. Okay. Otherwise, we unify if the size of PU is less than the size of is greater than the size of BV. We need to merge BV to BU. So size of BU plus by size of PV, and size of PV. No, I need to point parent PV need to point to BU. Point to BU. Okay. Greater, right? I will merge PV to BU and point PV to BU. Okay. I do the opposite for the L case. So I will in this case BV is greater, so I merge to BV. So child of BU here, and the parent of PU is point to BV. Okay, then I return can merge. Okay. Okay. What is unified data structure? What's this? Okay. I already implemented the unified data structure with the path compression here, and union by style. So now each operation now is O1. Okay. Now I just look through my row, right? Row. My row, and I merge them together. Row here, either row here, and row here is okay. Row in this one key, right? I have a key as row. Okay, and then for each element is the column, right? Column of row here. So I have a row column here. I need to unify them together because they have the same row. So I need to unify them together. I have a unified data structure here. Unify. I need to initialize the size of my unified here. So to avoid duplicate, I will no duplicate, right? This is and okay. 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 I need to initialize the size of my unified here. So what is the maximum size? The maximum size will be I will define the ID function. Get the ID function. Row and column. I need to return the ID of row and column. So how to get the ID? So I just for the row, right? I will multiply by look like the matrix. So I have a row here and column coordination here. For the row here, I will multiply by length of column and plus with column length of column. So the length of column maximum here, I need to get the maximum here. So we can use the fixed value like the fixed value like max column here. Can use the fixed value like this one. This one. Okay. Can use the fixed value like this. Okay. This is the coordinate. So need to plus 1 per second. Okay. Multiply by this one. Okay. So how about unify? I need to initialize for example max of row as well. So this one as well. Coordinate. So length of them. Okay. Okay. So I need to initialize maximum like this. Okay. Okay, I merge them together. Unify of union of row and unified one by one. Unified one by one. Unify one by one. So I need to iterate by index as well. Need to iterate one by one. I need to iterate one by one. So I will have the index here in range of length of from 1 into length of this one. This one I name it array for short. So I union file of the current get ID of row and array of I, the current here, okay, and the next get ID of maybe I iterate once is also good. I will store the last ID p-1 first. I iterate dummy also okay. Column here in this one of this one. Okay, I iterate them is okay. So I will have a last ID here and the current ID. Current ID will be row here with the column here. Okay. So if the last ID here is different to -1, I will union them together. Union row here and column last ID with the current ID together, and I update my last ID current ID. So it means that I will union all elements, all the point, the same rows together. I do the same with column. Do the same with column. Row here will column here. So I get my current ID here and I union file them together. Okay, union by column. Okay, after I union file by row and column, now I need to get my answer. Initialize my answer 0 here. So I have the union. Maybe avoid print out to console. I'm not sure what do you mean. Okay. Okay. I need to go through my union file and collect the size of each component. Actually, that we need to only collect the we need to find the group of ID, group of parent ID. Get a group of get a component IDs. Okay, component IDs. If you return a list of ID of the component, and this ID need to exist because I initialize a lot, right? I initialize maybe some point not existing, but I also add into my union file, right? So I need to have some add only some how to say some existing set or thing or something need to exist into the thing the point set or something point ID. Okay, for ID set something like this. So I will go through my this one and I initialize with the set here, and I need to modify function here into this one. Okay, then I need to add into my set add the get ID of row and column. Okay. So I need to traverse in range of length of my my side here. Length of my side here. Okay. If the index here need to be exact in my coordinate here, then I will have the set to eliminate duplicate. I will add the file of u here. I will turn that right here. Now I will have the component ID. Component as ID. So if I have the component ID, then I just iterate. So for the ID in my union file, get component ID. Get component ID. Get component ID of point ID set here. Okay. And this is for that I need to choose the maximum of the size union file size of ID -1 with the 1. Okay, return my answer. Let's run now. Load line 3 here. Line here for I in range n. This one I need to cast. Okay, this one cast into integer. Index is operand. Remember, like this one is equal to this one, return u. Otherwise, we find something operand. Something operand. So maybe something operand. So I will print up u and v. Why is it operand? 0, 1, and this one and this one. Why is 0, 1? 0, 1 because it's at the position 0. Okay, so let's bring row and column here. Okay, let's bring and apply to debugger. How to bring and apply? Okay. Okay. First it will the same row 0 here. First row 0 here. So we have duplicate, but duplicate is still fine now. So the row 0 here we have why we have a row 0 here, right? We have a column 0, okay, and column 1 here. Okay, correct. So it's still work until this one will out of index. So row 1, right? Row 1 we have 1 and column 0 and 1 column 2, correct. This one this ID we comment this ID to check way out of index. Okay. Mm. Okay. We currently traverse by rows, right? So row 0 here, we have column 0 here, this point, 0 here, column 1 here, this point. Okay, it's well. Row 1 here, we have column 0 here. Row 1 here, we have column 2 here. So merge them together. Well, uh, same with column with rows row 2 here. We have column 1 and column 2 correctly. But why is it out of index? Wait, out of index. We go through column here, right? Let's bring mm, and up rows, and this one we go a column, right? And this one row, right? Okay. Oh, it's not end up rows. It crashed something there. Why crash? It crashed by union 522. The union 522 is crashed, right? Let's bring here. Bring after union, right? Class ID and cur ID. Like union. Class ID and cur ID. Here union 0. Union 2 elements together, right? So 0, 1 together, correct? So the first one is row, right? Row I multiply by. Is it correct? Okay. And this one I union of this one and this one. This one is out of index. Okay, plus some buffer. Yeah, plus some buffer work. Okay. Five, right? Correct. Okay. 4 and 1, right? Not correct. Remove union. 5 correct, but how about 0, 0, 0, 0? I think it's not. And this how about it's only have how about it's only have one instant. One instant we don't increase, right? Right? 5, 3, 0, right? Okay. Our index. No, this one not like this. This one not like this. This one we initialize like this is not correct. Initialize like this is not correct because we need to max row multiply by max column. Max column is very big, so we need something like we use dictionary. Use dictionary for this. Don't initialize this first. Need to use dictionary first. Dictionary. We use dictionary. because if we generate by ID here and we initialize it will be number maximum row, right, multiply by column here, so it will be 10 exponent by 8. It will very bigger, so I change to use dictionary. Okay. If I use dictionary, I need to have a function like add is not is equal. I will add is not is equal. So if you, right, not in parent, right, I will initialize 1. I will define a function like add if not exist cell. So if it not exist, right, I will initialize by the Excel and the size by 1. Right? Okay. I will call this function for you and we to make sure they will initialize into my union file first. And this one I don't go through this one because I just going through my points is enough. Go through my point. Go through my point set ID, right? Okay. Then it just add by files of you. Okay, seems correct now. Actually, that keep this one. This one don't need to initialize. Okay, let's run. V is not defined. V is not defined. This is U, not V. File, right? So it's called add the not existing one. Why not existing one? Maybe it's don't exist into my union file, so it's not existed. So if you here is existed in my parent, so I will add into my list. Okay, seems correct now. Okay, quite hard for this question now. Maybe avoid bring out just DFS straightforward. Yeah, DFS can work. Okay, I choose to use union file and this work. So the time complexity here for this is simple. So I go linear time here, and this one go linear time as well. Linear time, and when I go linear time, right, I do the union file here because I do by back compression, both back compression by union by size. So its operation now here is O1. So this is a linear, and this also linear. So the time complexity will be linear time, and the by complexity will be also ON. Nothing special. How many line of code for the best function solution? Okay, I think we have 35 minutes here. So let's jump into question 4. Okay, given an m multiplied by n integer matrix, return the length of longest increasing path in the matrix. From Excel, you can either move in 4 directions: left, right, up, down. You may not move Dion, di, diagonal. How to say? Diagonal. How to say? How to pronounce this one? Diagonally, 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 or move outside boundary. Wrap around E, not allow. Okay. So for example, we have matrix here 9994668 211. So need to return the longest increasing path. So actually that's because we only move increase, right? You can either move four direction, you not move diagonally and move boundary. But for one cell, right, we only move increase. So for one here, we go 6 here, we go 9 here, and we end because we have nothing greater than 9 to come. So it looks like that if we deep S, if we go one way, it doesn't have a cycle. It don't go to the old node again. For example, the 1 here, we go 2 here, come 6 here, come 9 here. It doesn't go the same repeat again. So we just deep F to show this function, to show this. For example, that if we deep F to 9 here, right? So there is no next direction. So it will return Excel like 1. And for 6 here, this one cannot go, this one cannot go, this one cannot go, and it only jump into the up. And for the up here, we already have the result with just 1. So and this one, we just return the previous value plus 1. So for the cell 6 here, we return 2. Do the same. So link for the solution. Okay, for this is symbol, we have a DS here, row and column here, and we need to have a cache as well. Cache in Python we can use URL cache. So it will cache by row by params here and return the result. So we look our for direction. We DFS into the row column. Need to define our direction 0 1 0 1 0 minus 1 0 0 1 0 minus 1 0. It looks like a sync graph. So it's we traverse pair of 0 1 1 0 0 minus 1 and minus 1 0. Okay. So we traverse 4 neighbor. We need to check if it's valid or not. If it's not valid, we return 0. Okay. If row here is less 0 or row E have the number of row and column as well. Line of matrix 0 here. So it's read into the number of rows or column, this one, or column read into the number of column. We return 0 because out of bound. Alright. Or okay, maybe we check this one when we go to the next. We need to check. We need to check into this. So we need to have a new row and new column here. Equal row dir I here, column dir I plus 1 here. Okay. If new rows less, new row not valid outbound, we just continue. And or the next right, the next need to greater, need to greater than the current one. It is less or equal, right? The next one is less or equal, right? We continue. Like English or not greater. So we continue. Otherwise, we will leave S to new row, new column here, and we have the answer, right? We initialize by 0. We need to choose the one which have the maximum length for each cell here, right? We can try to find for direction and choose the path which have the maximum length. Look like a dynamic programming problem. Max of current answer. What this one first one. For example, what happens if this don't go through this one? So this one need to at least one. So need at least one, right? Okay. Turn answer here. Okay. So we just return this s of start from any cell. Try any cell. So row in range of m, column in range of n. We find the maximum of possible start row column here. Return our answer here. It looks like it's, our length here is 200, right? And my algorithm here is the time complexity will m multiplied by n multiplied by 4. So row and column here. 4, right? 4 here, correct? 4 here, 1 here. Okay, correct. Check my algorithm again. My year here, row here, column here, leave S here. At least it will have one element. Okay, I go through neighbor by row here, column here. If invalid, I will continue. Otherwise, I will choose the one which has the maximum length. I return my answer. I will try to choose the best one. Return. Okay. Okay. This one is moderate or easy as compared to previous. Yeah, this one is easier compared to the previous. This one we just dynamic programming. So I will analyze the time complexity. Actually, that I build my dynamic programming here, which is the number of stage will be row multiplied by column here, right? So m multiplied by n multiplied by number of inner loop here will be up to 4. And this one is a plus because I already compute all the result here. I already compute the db to d. So it will plus and the by complexity will be this db state will be m multiplied by n. Okay. Which one is the best for cache list of list or dictionary? Cache list of list. What do you mean by cache list of list? Cache a list, right? To cache a list in Python, we can use something like tuple. tuple. So tuple of this one, something like that. Any array here. If you make this one hashable, so that we can cache. In my answer, in my response, answer your question. No, I'm asking which one is the best for making DB list of lists or dictionary. Making DB list of lists. Sorry, I don't understand your question. Is the best for making DB list of lists. Actually, that here I cache the parameter here. So no parameter here need to be hashable because this is integer, right? Already hashable, and this is column, right? Already hashable. So you can cache. If you want to cache a list here, you need to make it a tuple. So we can cache. I think that's today's stream is. Let's check how many time we pass. Oh, we spent 2 hours already. So anyone have any questions? No, thanks for coming live. So no question, right? DBIJ, when I or J can be negative, you should use dictionary. I'm asking which the best for making DB list of lists or dictionary. You should use dictionary. Although it will be more clear to use list of lists. So let's consider if we have another approach to solve this problem. Okay, this is a dynamic programming way. Okay, dynamic programming is good enough. Okay. Thanks. That's my question. DBIJ when I or J can be negative, you should use dictionary. Although it should be more clear to use list of lists. List of lists you mean you mean like this, memo like this, or dictionary, or like this. To the array, right? Yeah. So actually that asset for the map here, right? Asset for the map is the structure. The its view not good compared to your asset to your array directly. So if you can access by using the list, for example, that in this case, right, you define the list like this, right? Memo here, you have the size will be initialized because we are finding the minimum, right? Maximum, right? We need to initialize minimum. Minimum may be 0, multiply by column. So if we it's of a row here, okay. So we just if memo of a row and column here is not equal to 0, then we return memo row and column here. Okay. Otherwise, this one I will cast right? You mean like this, right? Can is also the same. But I set this one. I set the memo here is a bit faster, right? Because you access the index of the random at the random index in the array directly. But this one you need to access something like a hash table, which is slower. So you can see, right? It's random. Sometimes it's fast, sometimes it's slower. So yeah. So like Huy, like Huy Nguyễn said that for if this one is a negative number, so you can use this one for more convenient. I think you already you are ready for fun. Let's apply. Thank you, Champion. So who is Champion? Can you make friend with me through Facebook? Let's go through question 3. Can we DFS? Didn't find quite long. Okay, how can we DFS? So we just have the graph, right? We just DFS for one point here. We can store the next. How to store the next of one element? From this one we go all we iterate all of them. So to DFS, right? We need to build a graph for a node. We need to find its next neighbor. Maybe we can have the binary search. A bit complex. Okay, I think that's all for today live stream. Thank you for you guys for watching. I see you guys on the next live streaming. I hope my live streaming are helpful for you guys. Thank you. Bye bye.